Hi, hello. In this video, we will be solving CSIR UGC 2019 June physics problem, and the problem goes something like this. The Hamiltonian of a classical non-linear one-dimensional oscillator is h equal to 1 by 2m p square plus lambda x square, where lambda is greater than 0 is a constant. The specific heat of a collection of n independent such oscillator is. So how do we solve this problem? So in this problem, h is given and it is given lambda is greater than 0, and we need to find the specific heat, that is Cv. Okay, so to start with, we know that Cv is equal to del E by del T V, and the E is represented as minus del by del beta ln of z, where z is the partition function. Now the z, that is the partition function, is written as z equal to 1 by h integration of E minus beta h dp dx, right? These are quite standard formula which you can check out from any book. So let us simplify. So z equal to 1 by h. Now if we substitute the value of h, it will be E minus beta p square by 2m plus lambda x square dp dx. Now if we divide, it will be E minus beta p square by 2m dp, and another integral E minus beta x square lambda dx. Now I added one extra integral, let me remove it. Now the next step is to evaluate. So if the integral is over minus infinity to plus infinity, it will be 1 by 2 gamma of half by beta by 2m, and this is 1 by 4 gamma of 1 by 4 by beta lambda 1 by 4. Okay, so if we take all the constant as c, and if we simplify, so this will be c by beta times 3 by 4, right, or c beta minus 3 by 4. So we get the partition function as constant times beta minus 3 by 4. Now let me just draw a line here. Okay, so the average energy E is minus del by del beta ln of z, which is equal to minus 1 by z dz by d beta. Now if we plug in the values, so it will be minus 1 by z, so c times beta minus 3 by 4 dz by d beta, so this will be 3 minus 3 by 4 beta minus 3 by 4 minus 1, so it will be minus 7 by 4. Now if it comes down, so if we simplify, this will be 3 by 4 beta, or equal to 3 by 4 kBT. If we calculate the specific heat, that is Cv, which was dE by dTV. Now this is the same formula which we already described. Then if we plug in the values, this will be 3 by 4 kB. Now for n particle, it will be 3 by 4 n kB, right? So the option B is the correct answer. I hope you understood the process to solve this problem, but I'll still try to explain you once again. So the h is given in the problem. Okay, we know the expression for Cv, and we try to find the partition function. After we get the partition function, we use this in the expression for the average energy, and after getting the value of average energy, we use it in the expression for specific heat to get the specific heat value. Now for n independent such oscillator, it will be multiplied by n. So here we go. The answer is option B. If you like this video, do subscribe to our channel. We upload similar videos in the channel, and have a nice day.